Okay, so in this video, we're going to be solving problems involving the triangle inequality theorem and maybe the triangle angle sum theorem. Okay, so if we're going to do this here, right, this problem, it says that we have a triangle called ABC. So first I need to draw this, right? It says sketch a picture. So it's really helpful if we can see the picture. So here is triangle ABC. Ooh, that's great. So here's A, there's B, and let's call this C. Okay, so let's make it a little bigger. So A is 43 degrees. Ooh, that's not right at all. Let's see if I can erase that. Much better. Okay, 43 degrees for A. That's a 3. 43. B is 71. So the first thing we have to do is figure out the measure of angle C. So we're going to apply the triangle angle sum theorem. So we have a 43 degree angle and a 71 degree angle, and then angle C. So we add these two together, 43 and 71, and we subtract that from 180. So let's see, what is 180 minus 43 minus 71? That comes out to be 66. So this one here is going to be a 66 degree angle. Okay, so now that we know all those angle measures, well, that says 66. My writing utensil is not so sharp. So now that we know that, we can list the sides from longest to shortest. Okay, so the longest side is across from the longest angle, or the largest angle. So this one is 71 degrees, which means the side opposite is the largest side. So CA is the longest side. Okay, and then we have 66, and the side across from 66 is this one. So 66 comes here. So we have AB. And then the last one clearly is going to be the one across from the 43 degree angle. In other words, C to B. Okay, so this is the largest, right, from longest to shortest. CA is the longest side and CB is the shortest side because CA is across from the largest angle. So that's what the triangle inequality theorem says. Okay, next one we have another triangle ABC. So let me see if I can draw this one nicer with my pen now. Okay, so here is A and here is B and here is C. So A is 6x plus 4 degrees and B is 12x degrees and C is 6x plus 8 degrees. Okay, so we need to solve for x. So we need to figure out how all three of these angles relate. Well, the triangle angle sum theorem says we can add up all of these angles of a triangle and they have to equal 180. Okay, so that's what we're going to do. We're going to add up angle A, which is 6x plus 4, to angle B, which is 12x, to angle C, which is 6x plus 8, and all of those things have to add up to 180. Okay, so we do all of our combining of like terms. Okay, we subtract 12 from both sides. And then we solve for x by dividing both sides by 12. And we get x is 7. Okay, so x is 7. Super. Now we can go back in and figure out what all of these angle measures are, right? What's their actual degrees? So let's go ahead and do that. So 12 times 7 is 84. 6 times 7 is 42. 42 and 4 is 46 degrees. And then 6 times 7, well, that's 42 again, and this one is 50 degrees. So we're going to list the side lengths in increasing order, so from smallest to largest. Okay, so if 46 is the smallest angle, that means the side across from it is the smallest side. So CB is the smallest. Okay, and then we have 50 degrees. The side across from 50 degrees is this one, AB. So AB is the next smallest side. And then clearly, the largest side has to be the one we haven't talked about yet, the one that's across from 84 degrees, which is AC. So here are the side lengths in increasing order from smallest to largest. Okay, number 3, two sides of triangle BEN are 15 and 9. All right, let's draw a triangle BEN. So we have angles B and E and N. And one side is 15. Let's make this side 15. We'll make this side 9. So the question is, what are all the possible lengths for this third side? Right? So what's the smallest possible? If I took B, E, and N and I made it really, really skinny, right? This is B and this is E and this is N. What are the possible lengths for this third side here? Okay, and we find the smallest one by subtracting. So 15 minus 9. 15 minus 9 would mean the smallest possible thing is 6. Okay, but it can't be equal to 6. It has to be 6.01. So rather than using a real number, we just use the less than. So 6 is the smallest possible thing. Okay, and then what if we were to open it up a whole bunch, right? So this is now BN, and E is way over here. Okay, what would be the largest that it could possibly be now? So with, once again, 15 and 9, we have to add them together. So 24 would be the maximum size. So it has to be bigger than 6, but less than 24. Anything in between there would be fine. So this is the range of possible lengths. Okay, not just one, but all of them have to be between 6 and 24. Okay, in triangle XYZ, side XY is less than YZ, and side XZ is less than XY. Okay, so let's write these things in order. Okay, the first one says that XY is less than YZ. And then it says that XZ is less than XY. So that means it goes here. XZ. So it's telling you what side is the smallest and what side is the largest. So XZ is the smallest side and YZ is the biggest side. Okay, so what happens in a triangle, if you have, right, side XZ, if this is side X and Z, then what is the letter of the angle across from it? Well, it's the only one left. Okay, so if XZ is the smallest side, that means angle Y must be the smallest angle because angle Y is across from side YZ. So let's use that same kind of logic to figure out the other ones. Okay, if I were talking about side XY, which is here, then angle Z is the angle across from that one. So Z would be the angle that corresponds with side XY. Okay, which means that X would have to be the largest of the angles. So Y is smallest, Z is next, and X is biggest. So let's see. XY, nope, that one's the opposite way. ZY, nope, that one's not right. YZX. This one is the correct thing because that's in the correct order that we put it here. Okay, so if you know two sides or the letters for the side, then the angle across from it is the one that we don't use. Okay, so that's Y, and that's Z, and that's X. Okay, pretty sneaky, I know. And lastly, we have this wonderful problem. Okay, so once again, we're having to employ the triangle angle sum theorem because we know the three angles of a triangle. So 75 plus X plus 4X, we add all these angles together, that has to equal 180. So if we combine our like terms and we use our amazing algebra skills, 180 minus 105, divide both sides by 5, we get X is 21. Okay, Okay, so now let's plug that in. DFG. So F is the letter in the middle. So D to F to G is this angle right here, 75 degrees. Okay, we're looking for the letter in the middle. D is this angle up here. 4 times 21 is 84 degrees. And then G is the letter in the middle, so that's talking about this angle here. FGD must be 21 degrees. So list the sides in increasing order. So if this is 21 degrees, then the smallest side is going to be DF. And then we have 75 degrees is the next one. So across from 75 is DG, which means the largest side is going to be GF. And there we have listed the sides in increasing order. Okay, so these are the things you're going to be required to do with these type of problems. Number 1, adding up triangles to 180. Okay, 3 triangles, all the 3 angles of a triangle always add up to 180. Okay, and then the longest side is across from the largest angle. Okay, and the letter of the angle is the letter that's missing from your triangles. Okay, and then to find the third side, we subtract the 2 given sides to find the smallest value, and we add to find the largest possible value. Okay, and that's how you do these triangle angle sum and triangle inequality problems. Hopefully this helps.